let me introduce you to Dr. Se Kim, who has joined us. It is such a privilege and honor to have you here. And even though you're not here in person, we are so thankful for your ministry. And so I want to do just a very brief intro of Dr. Kim, and then she's going to walk us through a journey of why she is qualified to be speaking about these things today. She's very humble. I have been so privileged and honored to get to know her. When I reached out to Dr. Francis Collins, I said to Dr. Collins, who would you recommend? He said, without a doubt, Dr. Kim. And so I shared that with Dr. Kim, and of course, she's very humble, so she didn't take the compliment too well. That's a gift. And so I want to introduce you to Dr. Se Kim. She happens to be married to a pastor who is the Reverend Dr. Peter Hong, who is a pastor in a Virginia suburb of Washington, D.C., and he is doing his pastoral work this afternoon, and we're thankful that Dr. Kim could join us in this way. Dr. Kim will share more specifically about her academic journey, but I want you to know she comes to us as a gifted scientist. She is a geneticist. She is also a biologist and a neuroscientist. And so the best thing about Dr. Kim so far is that she knows so much, but she presents it in a way that is humble, engaging, and accessible. So Dr. Kim, welcome. We're so honored to have you come and share with us today. So take us on a journey of introducing yourself to us, please.
Thank you. I'm very honored to be here. And because of the virtual world that we live in, I just want to make sure that sound is okay for everyone. So if the tech team will just let me know if there's any issues or stop me at any time. It is great to join you virtually. Thank you, Pastor Jeff, for your warm welcome and introduction. I'm delighted. My only sadness is I can't be with you in person. But hopefully one day very, very soon. So I'll get started. The way that Pastor Jeff and I discussed doing this is doing it in bits where he would prompt me with questions and I would speak a little. And so we're going to jump around, and as well as scientists are trained to be non-functional without a PowerPoint. And so I have to use PowerPoint here. So as Pastor Jeff said, my name is Se. I am a scientist by training, and I'm also a committed follower of Jesus Christ. And the topic I know of today's courageous conversation, that you're courageous in participating, is science or faith or both. And I frame it a little bit different, saying finding spaces for new stories, because I find that so often we hear the emphasis on or and not so much on the and, being able to do both. And so just a little bit about me. I grew up and studied in Texas, which means if you ask any Texan what the United States looks like, this is what they'll say, right? And so I don't live there anymore. I'm coming to you live from Washington, D.C. / Northern Virginia, but this is how forever the U.S. would look like to me. I grew up in a Christian home. My parents were Christian, and this is a picture of my father who passed away a year ago. But I really like this picture because it shows what our stories are. We're all a story of who we are and our biology, and as well as ourselves, what we experienced, how we grew up. And this is my dad. We had just walked and hiked through the National Glacier Park. And he is just, actually, he's probably just exhausted, but he looks like he's reflecting. And my parents were very much reflection of nature in how they celebrate God's creation. And they instilled that curiosity and that wonder in me. And that's how I felt the call to go into the sciences. This is just a quote from John Muir, who's a naturalist in the 1800s, and he was pivotal for the creation of the national park system. And he says, no synonym for God is so perfect as beauty, whether as seen as carving the lines of mountains or glaciers or gathering matter into stars, planning the movements of the water or gardening, all is beauty. And so it really summarizes how I view nature. So what did I study? So I studied at the Baylor College of Medicine on neuroscience and genetics, particularly the DNA in our brain and how that functions in learning and memory. I continued to study that at Rice University doing my postdoc in a model system in plants, because it turns out plants have memory. So as a side note, plants have memory because if you think about seasons, they remember every seasons and they respond. So I did plant research for a while, and it was during this time that I realized I really like administration and public engagement. So I joined the American Association for the Advancement of Science, which is the world's largest general science organization. And they're unique because they have a program called Dialogue on Science, Ethics, and Religion, which facilitates the dialogue between scientists and religious communities. And I hope to grow that program for a while. And then I am currently at the National Academies of Science, Engineering, and Medicine as a director of membership and governance for the medical medicine part. And the Academies is responsible for advising the country on important policies pertaining to science, engineering, and medicine. But it is at this juncture, that's a picture of me in the lab at like 2 a.m. in the morning when I dragged my husband to lab because I needed to do an experiment. But this is at this point, I must do a disclaimer that the opinions expressed here do not represent those of my employers, past or present. So just slipping it in there. And as life is, it's a journey, twists and turns. And then while I'm doing my research, somewhere along the line, I found myself married to a pastor, which was a surprise to me as well as probably to everybody. But this resulted in really having those types of science and religion faith conversations. And so I'm happy to say my husband and I continue to marvel at the wonder of the world. And I am not kidding if science and religion is literally our dinner table conversation. So you're welcome to join me at any time. So that's a little bit about me, and I'll pause there because I think Pastor Jeff has some questions, I believe.
Exactly, because Dr. Kim, you have a specialty. Your specialization is epigenetics. So can you walk us through that and tell us what epigenetics is? And I know that you have extensively studied learning and memory in particular. So tell us a little bit more about that, please. This is really fascinating.
Sure. So back to the slide. Okay. So let's start off with the big picture of memory. We all know what memory is, but we'll start off with the definition, which is the process of recalling what has been learned and retained, the store of things learned from activity or experience as evidenced by outcome. So essentially is we have an input, we process, and there is an outcome. And that outcome biologically, as in definition of memory, could be a cellular change, or it could be a behavioral change. So if I learn information, my behavior change, that's could also be a biological impact. PowerPoint. There we go. In a biological sense, one of the points that I wanted to carry forth today, which is that all of our cells, and when instead of just thinking about a brain, all of our cells have a component of cellular memory or biological memory. And we as humans are a combination of our cellular memory plus our experiences. And that makes us who we are. And it's a feedback, because remember, memory is a change in outcome. So we experience something, how we worship, what we eat, it interacts with our cellular systems, and that in turn changes our physiology or changes our behavior or outcome. So that's one of the themes. So what I studied is a little bit deeper, but if you want a funner version, I often say, I'm a fan of Pixar, not that they pay me, but you can watch this movie, which has a really good job of showing how short-term memory goes to long-term memory. But if you want a biological sense, maybe a boringer version, but memory will start in the hippocampus. We'll start at the brain. Memory stored in the brain. I studied a region called the hippocampus, which is responsible for short-term memory to long-term memory storage. It is in this brain, if we zoom in a little bit at the cellular level, the brain is composed of neurons, and there's about 100 billion neurons. And they say it's about, the galaxy, the stars in our galaxy is about 100 to 200 billion. So you can imagine how complex our brains are if we have as much neurons in our brain. So this is a neuron, and neurons are interesting cells because they have this long arm called axons and dendrites, and they connect to each other at junctions called synapses. And there's this idea that in cellular memory of brain, of our neurons, how it's encoded is when we experience something, the relationship between those neurons through their synaptic junctions gets strengthened. And so the more that we remember something, that relationship gets strengthened and encoded in our neurons, multiplied by 100 billion neurons. And so the scientists call this a classic Hebb's postulate named after Hebb. It's called neurons that fire together, wire together. So what I studied is what actually happens in the neurons, in the nucleus of the neurons, in the DNA. So all our cells, there are DNA, and they say it has a genetic code. They say about 6 feet in each of the cells. You scrunch it all up and that's in one cell. So it's quite a lot of genetic information that makes us who we are. Well, what I studied is that in the DNA, we tend to think DNA is a history of who we are, codes all the genetic code. But there's this idea of epigenetics. Epi, if you studied Greek, I did not, it's the only Greek word I know. Epi means on top of, and there are these molecular markers on our DNA that's able to adjust how this DNA is formed and how this DNA is folded into the cell. You can imagine it's a very long DNA. It's not just jammed in there. There's a sense of order in there. And that is regulated by these molecular epigenetic markers. And whether, depending on the markers, what they are and whether they're there or not, it can open up the DNA to turn genes off or turn genes off in a light switch manner, more like a dimmer. So it has a lot of degree in how it can control whether a gene's turned off or on. So what this means is that if we zoom out a little again, we zoomed in to the cells, now we're zooming back out, is that when you make changes in our experiences or whatever we come across or learn, it changes the epigenetics on our DNA structure, what genes are turned off and on, proteins are formed according to the central dogma, and our cells shapes change. Again, we're going back to the neurons changing in the synaptic strength, going in those connections. So a very good example I often use is a chocolate ice cream example. I like chocolate ice cream. I go to the grocery store and I say, where's the chocolate ice cream? And I ask the grocery store person there, they say it's an aisle, whatever. I come home. I know the fact that I know that I like chocolate ice cream is long-term memory. I've already forgotten where the aisle is because that's short-term memory. In the encoding of the long-term memory is that every time I eat and remember that I like chocolate ice cream, those chocolate ice cream neurons get strengthened because the DNA in those neurons changes and the epigenetics changes and strengthens those relationships within those neurons. Multiplied again by 100 billion neurons, and you have all the knowledge and experiences that we can encode in our brain, which is quite amazing. So a couple of points about epigenetics. Epigenetics connects our genes with our environment. So decisions and interactions with our environment, what we choose to do or eat, create cues in our epigenetics or epigenome when you talk about the whole genetics or genome of a person. The molecules, the molecular molecules of the epigenetics dictate which genes are turned on and off. Cells change their shape, again, structural changes, and we are behavioral changes. So it's a way to encode our experiences to a different outcome. And epigenetics is very important in a lot of biology and a lot of health conditions, including neurodegenerative disorders, autism spectrum, and even the gut microbiome. And so it turns out our gut microbiome impacts our epigenetics, and therefore also there's this idea that impacts our health of our brain. So I'm just saying, I like chocolate ice cream, it's my bacteria, it's not me. So 3 points about epigenetics, which I think raises very important questions and interesting questions. First is epigenetics tells us that environment and choices matter. What we choose to do, what we choose to eat, for example, if we choose to eat healthy, that has physiological health outcomes. If we choose to eat poorly, that also has health outcomes, right? It's quite intuitive. What's interesting is that epigenetics also tells us that some of our experiences may be heritable to the next generation. Here, I ask people to take this with a grain of salt because it's very easier to examine this in animals that we're able to test. So for example, in rats, the classic study is that in rats, they were able, who like fruity smell, rats like fruit, so they like fruity smell. They were trained to hate the fruity smell because it was associated with an electric shock. So they know that every time they smell the specific fruity smell, they're going to get a shock. And so they learn to avert that fruity smell. And you can imagine that that rat perfectly learned it, behavioral change and outcome. It turns out that that rat's pups, so the grandpups, which have never seen the fruity smell or the electric shock, if you expose them to the fruity smell, they now say, oh, wait, I don't like this fruity smell. Turns out that their epigenetics has changed and retains the change from what their grandparents have. Now, the interesting point I should reemphasize is this is not a genetic mutation. Their DNA sequence is fine. It is how those genes are expressed in their smell receptors and the olfactory that changes how they respond. And so it brings up a lot of questions. So the other observations that people have made, scientists have made, is a study on the hunger, the famine in the Netherlands, the Dutch famines after World War II. It turns out that the babies that were in the womb during the famine after World War II in the Netherlands, they had bad health outcomes as expected. Their moms had a really rough time during the famine. But now that we're away, many years away from World War II, we're finding that their grandchildren have health outcomes that's not present in the grandchildren of those who were born before the famine or after the famine. So it's not a genetic impact. There's health outcomes that is recorded by the epigenetics somehow that transfers it through generations. And it brings up very many questions about what is inheritable and what is not. And what we experience could actually have impact in our progeny and children's children and so forth. The third point is that epigenetics tells us that change can over time be reversible. So it is not permanent. We see this in our brain. Our brain is very plastic, able to take over certain other parts. But the idea is, even if you made a choice to eat poorly, later on, if you reverse and try to eat healthy, it will be able to reverse, and you're able to reverse the epigenetic changes and therefore the impact later. So the three things about, again, cellular memory or biological memory that epigenetics tells us is that we are environmentally dependent, it may span generations, and it is reversible. So that's a little primer on epigenetics.
Okay, Dr. Kim, before we go to the next section, I listened to you present at the Nazarene Theological Seminary, which was a seminar that was centered on youth and youth ministry. Mm-hmm. Now, this whole topic of epigenetics, why is it important for youth in particular? What's the implication here for youth?
Well, at that event, which was for youth pastors, and I think in general, what we know about youth brain, the emphasis that we made is that youth brain is still developing. Humans are unique because we continue to grow after the womb, and our brain specifically continues to grow. The same reason why driver's license insurance is really high until 25, 26, because the brain, the idea of control, critical thinking, that continues to develop into the late teens and early 20s. And so what that means is that if anything, our choices, anything that the teens do, those have physiological impact that can last not only for them in their adulthood, but also their children's children. And so it does bring up a lot of question about how do you advise them, right, to live the life that is best for them and to make the choices that are wise. But it also helps us to understand, for those of us who work with youth, to give them the room and the grace to know that they're still growing and that they're still learning really physiologically in their brain as well.
And one other thing, Dr. Kim, before we move off of the topic of epigenetics, because I really want people to see the relevance, if you will, for this whole conversation. So for people who've experienced trauma in their life, how does epigenetics inform the topic of trauma?
That's a really tough one. I know, so scientists are looking very deeply into that, because we're realizing that we are obviously not just a product of our biology, but also a product of our experiences and what we've experienced. And unfortunately, bad things happen and people experience trauma. And so all I can say is that while studies are very preliminary, we do know that experienced trauma has physiological, whether they're expressed mentally or whether they're expressed in our, other parts of the body, has impact in the individual's outcome. The question and the big unknown is, would for example, something like a psychological trauma impact and be carried forth in later generation? And that is a very big unknown. A lot of, as you can imagine, we can't isolate humans. We interact, we live, we can't experiment. So what that means is a lot of our studies are correlation, this population versus that population. But correlation, as they say in science, does not mean that it's a causation. So we have to be very careful, but it still begs the same question of, how do we make the choices and how do we help those?
So, Dr. Kim, is it possible that a person will be carrying the effects of trauma from previous generations? And
it is possible in the sense we see it in animal models.
Okay.
It's too complex. Our human biology is too complex for us to say this trauma equates to this epigenetic changes on this gene for this human, right? It's hard for us to make that connection because so many things, so many genes impact one outcome. And we're very complex, but based on animal models, we do know that certain things can be identified. So for example, with the rat example, we do see that epigenetic changes in generations later, the same epigenetic changes are retained for them to not like this particular smell.
Right. Okay, we have a question from a viewer before we go into our next section, because it's a great way to enter into the conversation about the relationship between science and religion. I'll just read the question, if I may. Mm-hmm. My youngest son, who grew up in our Christian home, had been active in church mission trips, went to Baylor University, is now a computer programmer, and founded a nonprofit to help underprivileged kids in Dallas. He taught them, let me back up, founded a nonprofit to help underprivileged kids in Dallas learn how to code, began questioning his faith while at Baylor. The quote from Carl Sagan, "Extraordinary claims require extraordinary evidence," seemed to be the catalyst for his journey into doubt and skepticism. So how do you approach intelligent young people who say they do not see the evidence for God and that science will eventually provide all the answers?
There's a lot folded into that question, so let me try to break it down. First of all, I commend the family to bringing that question, but because I think our church family do need to discuss things like this. Can you read me the Carl Sagan quote again? Because I wanted to spin off of that one.
Yes. Extraordinary claims require extraordinary evidence.
Thank you. So a counter, I think the dichotomy that science and religion, that you must choose one, is actually quite false. And I'll show some framework to go into that. But it is a false dichotomy. There are many that do not feel the same, that science and religion can get along. And I think that the unfortunate is that, the information that we're provided from the public sphere, often those largest voices are those that they say that science and faith cannot get along. With regards to that extraordinary findings that Carl Sagan, I think a lot of scientists who are religious or Christian would say that as much as scientists say, the interesting thing about science is that it is, Einstein said, it's wonderful that it's understandable. The remarkable thing about science is that we can understand it through mathematics and physics, right? But believers can also say the same thing. The remarkable thing about faith is that it is understandable, that we're able to understand God or know God. But the difference is here, science is based on experiments of what we can see in our physical setting, whereas faith is based on historicity of testimonies and the Bible. And there is a confusion between trying to understand faith in the context as a science textbook, trying to understand the Bible as a science book, versus understanding the historical, what they say, the historical referentiality based on real people, the stories of real people and real events. And so we should not confuse the two. So again, the 2 points are, the voices we heard are often those of dichotomy, which is actually not true. And I can go into a little bit more of that framework. And second is, let's not confuse that just because we can explain away something doesn't mean that takes away from the marvelousness of something. And in fact, the opposite is actually dangerous. If we say something is too complex to understand, therefore it must have been God. Well, if God is outside of creation and created everything, he would have understood it. And at some point, if we understand it, is our faith based on Jesus Christ, or is it based on the fact that we can explain it? So it seems like, where is our faith on? Where's our faith resting on, if that makes sense? Are we resting on the fact that the logics, or are we resting on the personhood of Christ? Right. So lot to untangle, but I can give more framework as we go through.
Okay, let's move into this whole dialogue between science and religion, because Dr. Kim, one of the things that you're going to emphasize, I believe, is that they don't have to be foes. They can be very, very friendly, right?
Mm-hmm. Yes.
And for those of you who are just joining us, hear that. This does not have to be antagonistic. So take us through this section, please.
Sure. So so again, we're faced with the question: science and religion, are they opposite? Must we pick from either or? And sometimes in these conversations, it's helpful to give some framework of how others think about this, because so often, as I mentioned, we only hear about the conflict, that when you must choose one or the other. So just to give you some framework again, I'm having some technical difficulties, seems like. Oh, I don't know what's going on. It skipped a slide. It skipped a slide that I wanted to show you. So bear with me. Okay, all right. Back to PowerPoint. All right. So again, majority of Americans, it's interesting because the science and faith conversation in terms of are they in conflict or are they not is actually quite American conversation. And so I just wanted to frame and give you some data points, which is majority of Americans, as we know, are religious, and therefore they have they're faced more so than other countries with this dichotomy. And in 2015, the Pew did a research where they asked Americans, and it's actually still fairly holds true today based on more sociological data, whether Americans generally think science and religion are in conflict. And it turns out, obviously, nearly 60% say it is in conflict. The interesting thing about this study was that when they asked them, do you think science and religion conflicts with your own religious views? It turns out that only 30% say this. This data shows us that they're in the public sphere. There's this perception that science and religion are in conflict, but each person individually may not feel that conflict. So are we being confused by the public perception when the perception is not accurate? And that's the question. Again, going back to this framework, excuse me. because it's helpful. This is a classic framework that was set aside by Ian Barber. Other scholars have added to it, but it's the idea of how science and religion can interact. And the first one is contrast and independent. And this is what Stephen Jay Gould used to say as non-overlapping magisterium. And, oh, looks like I was sharing the wrong screen. So in non-overlapping magisteria, the idea is that science and religion really don't have anything to do with each other. They're their own ways of seeking truth, and they shouldn't really interrelate. The second version is a conflict, which is at the bottom, which is the idea that they both are seeking truth, but you don't really need the other. You only need one, and only one is the right way to go. And that's the message that most Americans see. The third is the contact, and it comes in different forms: dialogue, integration, collaboration. And it's actually where a lot of conversation can actually happen. Dialogue, science and religion can be in dialogue. They can integrate some ideas, and they can even work together to find solutions. The important thing is conflict is not the only way. There are other ways, and sometimes it could be topically driven. Some topics you may find that science and religion communities don't get along, but in some ways they can come together. Another way to think about it from a faith perspective is that, and Pastor Jeff could probably explain this more, but even the Bible tells us about general revelation and special revelation, and this idea that we see what we see in nature that tells us, God as a creator and the wonder and marvel. And that is general revelation, one way of knowing about God. The other way is through the Bible or our faith, and that's special revelation of Jesus, right? So as God and as an initiator is what John Polkinghorne, who's a physicist, but also an Anglican priest, says, that in special revelation or in learning through theology is God is initiating the relationship, whereas in science, man is initiating through experiments, but they're all pointing to truth, or they're all ways to find out about God. And so again, the idea that you must only reserve it through one way is not necessarily the only way to think about this, that both allows a way to understand and know God. In the Jewish tradition, this is Rabbi Jonathan Sachs, and he says science, he goes on to say science is about explanation, religion is about meaning, science analyzes, religion integrates, science breaks things down, religion binds together, and reinforce this idea that science is about understanding the physical world, but religion is about the one-on-one, the relationship. And if we think about Christianity, right, it is about the relationship of humans with God. It's about the uniqueness of humans, and it is about how we come to know him as a person rather than just trying to understand. Another way to think about this is the how versus why, right? How something works is a different question than why is that something there? And that's another way to think about going at truth together. Francis Collins, who I actually did not realize even knew who I was, and I'm very humbled, like Pastor Jeff said. He actually, if you don't know, Dr. Francis Collins is the head of National Institutes of Health. He recently actually retired. He said that he was going to retire after a long, illustrious career, but he's also a committed Christian. And he says this: there are answers that science isn't able to provide about the natural world, the questions about why, instead of the questions about how.
Right.
And these are questions, and I just list them up. There's a lot, but they're questions of identity, who we are not biologically, but who are you, right? Like what makes you, you, meaning and purpose, significance, uniqueness, suffering and beauty, and other things like awe and wonder. And so this is just to say, we can't stop at the science, right? We have to engage both aspects. And I kind of mentioned back to this idea of news stories. And this is a quote by a scientist who participated in one of the science and religion dialogue programs. He says, "The voices most often heard by the public are those seeking to emphasize a rift between science and belief, but the voices most needed are those recognizing the compatibility of the two. So I often challenge both those of us who are in church and both scientists themselves that we really need to break down the myth of scientists in society. So again, going back to, the question about the Carl Sagan and the influence, he's a great scientist, but the myth that we see in public, I like sci-fi movies and crime shows and all of that, but they do perpetuate a myth, right? Scientists are cold, disengaged, they don't care about religion, but it's actually really not true. And I encourage all of us to really look at the stories of real people out there, and people like Jennifer Wiseman, who I used to have the honor to work with for a while with the Dozer program. Dr. James Tour is a professor at Rice University, and obviously Dr. Francis Collins. So Dr. Wiseman, who's an astrophysicist, says it's not, there's no reason to feel despair. Some people might feel despair in space, but really it's about significance. How significant are we that God cares for us, right? And other quotes, as you can see from Dr. Tour, Dr. Collins. So that is it. We can go on to questions and more discussions, but I want you to have my email in case anyone wants to reach out. But that's a little blurb primer on science and religion.
So thank you, Dr. Kim. So let's put some more meat on the bones, if we may. So relative to science and religion, I want to just go there a little bit more, if we may, because in terms of Genesis, and on Wednesday night in our follow-up, I want to get more into the complicated details of this, Dr. Kim, because we have to understand that the book of Genesis, in describing the creation of the world, is not focused on how God did that.
Mm-hmm.
The focus of Genesis is why. We trust science for the how. Our job in the religious realm is to focus on why did God do this?
Right.
Now, that's what you were saying already, correct? And when you take a look at the book of Genesis, you have some people who insist on a young earth, 6,000 years old. Why do scientists say that's not even possible?
So science deals, science deals with what we can see and observe,
Right.
and the idea of being able to experiment and reproducibility of data, right?
Mm-hmm.
Whereas, again, I mentioned previously, Bible is, let's not confuse, reading the Bible as a science textbook,
right,
versus the historicity of the Bible, right? Like that it covers people and actual events and the stories about what makes uniqueness and what brings purpose and meaning, right? So first, recognizing that the worldview and the viewpoints and the purpose of the two ways of knowing truth and two ways of knowing God are different. And so because scientists have to deal with observable data and experimentation, it does show that humans or humankind's, I say humankind because it's a whole nother question to ask what makes us human. How do we know at what point was human? That's a whole nother, both a theological question and a scientific one. But anthropologists and archaeologists, their conclusion is that humankind was probably evolved 200,000 years ago, years before present. But in the Bible, based on genealogy, it's probably around 4,000 to 6,000 years. But we can go a little bit deeper into this. I don't know which direction you want to.
So Dr. Kim, the only thing I'll say on Wednesday night, what I'm really going to emphasize though, is that you get different types of genre at work in the scripture. And I'll explain that on Wednesday night. We won't go into that now because I want to glean from the wisdom of Dr. Kim. And so I just want you to know, if you have curiosity about Genesis, then come on Wednesday night, because I'm going to deeply delve into how that book in particular is not in competition with good science.
Mhm.
We know for a fact, Dr. Kim, correct me if I have this wrong, that the age of the universe is about 13.8 million years old.
Billion, I think.
Billion?
Billion. I'm not, this is where my lack of physics tells you that it's starting to show. I know the number is 13.7 or 8. I want to say billion, but I might be mistaken now. It's embarrassing, but yes.
See,
We'll have to look it up. This is what
that's
Google's
what I mean by
for.
your humility. But the point is that billion is correct. We have a person who
Thank you.
it is billion. So I don't know where I got million. My mind just couldn't get wrapped around this billion. But here's the thing, is that the book of Genesis, in my humble opinion, does not in any way find 13.8 billion to be a threat. So we'll explore that on Wednesday night. It does not have to be a foe. It does not have to be an enemy. And on Wednesday night, we'll also talk about dinosaurs, because a lot of Christians, I have a neighbor who said to me, who insists that the world is 6,000 years old. That person said, I just want you to know that dinosaurs did not exist. See, that's the only way you can deal with a 6,000-year-old Earth, right? Is you have to say, well, something's got to go. So in their viewpoint, the dinosaurs go. So we're going to talk about that on Wednesday night, Dr. Kim, but I want to glean from your wisdom. So we're going to move subjects a bit, okay?
Mhm.
And that is that as we look forward to the future, you as a geneticist have spent some time working with artificial intelligence. And Dr. Kim, you have heard me say that in my humble opinion, that whole issue of artificial intelligence and genetic engineering is going to become the ethical issue of the 21st century, sooner or later. Would you agree or disagree with that statement?
I think that is very true. I do want to, can I take a side note? Because I do want to say one thing about this Genesis thing.
Okay.
I concur that the Bible does not, the Bible is silent on the creation, the de novo creation of Adam and Eve, as it is silent about how the resurrection happens, and we don't understand it. And so I think there is a lot of room, I'll just say that there's a lot of room, as you said, to understand and study those two, that issue. And I think I would just say that there are a lot of different viewpoints to this, and happy to dive further, but I just wanted to say that there are a lot of unknowns in the Bible. And again, going back to making sure that it does leave room for a lot of these interesting questions. Right. Back to AI and genetic engineering. We're looking back with Genesis, but we also look forward. The questions raised by genetic engineering and AI are actually, interestingly, the same questions that are raised by where we come from, right? So it's questions of things like authority. Do we have the authority to create AI? Who has the authority? It's questions of purpose and meaning, and a question of uniqueness. What makes us unique as human is the exact same question, whether we are talking about genetic engineering or Adam and Eve or artificial intelligence. Mm-hmm. If artificial intelligence, for example, reaches singularity, as they say, where they are self-aware and conscious, does that mean that they are human? What defines them? At what point do they become human, right? And so again, it's these theological why questions. They're the same under the sun, as they say. And we can dive deeper into that if you would like. Yeah.
So, Dr. Kim, for those that may not be as aware or may not have had as much exposure to what's really happening with AI, why is it a potential? I want to underscore potential. Why is it a potential threat?
So let me show this slide because I think it helps outline our thoughts So regardless of what that is, regardless of, genetic engineering or AI, it's really about emerging technologies. And as I mentioned, why is it an issue? Well, if we take AI, we often think about things like driving cars, but we also think about who has access, right? If we're thinking about access to AI to make our life easier or to make our jobs easier, who has access? And is it fair that some have access and some don't? And how would that change how we relate to one another? The other thing about uniqueness about AI is that we build AI, right? Humans build AI. So our biases, our impressions of what we know and what we don't know, and the things that we don't know, all of that are programmed into AI. And we carry forth our flaws too. If we carry forth our intelligence, we carry forth our flaws. And if we do that, would that artificial intelligence also have the same biases, which is very dangerous, right? Biases like racism, biases like prejudice, would that also be carried forward? And who's responsible? How do we hold each other accountable? And then, as I mentioned previously, authority, right? Who builds it? Who partakes in building it? As much as creating, the love of creating, like art, that could be a very godly character, but is that impinging on authority somehow if we're enhancing humans, for example, through AI? So a lot of these questions, whether they're AI or any other emerging technologies, the issues raised, again, I think I outlined here, are on these three categories.
Yeah, well done, Dr. Kim. The other thing I wanted to ask about this, and then we've got to get to the questions because they're starting to pile up here, and that is Dr. Dawkins, or Professor Dawkins, as he's called in the UK, even though he's deceased, he said that if we're not careful, that AI will actually have the potential to overtake humanity as we understand it. Is that true? Is that a threat?
I think it poses on the assumption of, first, that AI will reach, as they say, singularity or consciousness. And in my opinion, it's a little bit bleak thinking, but I think, again, it emphasizes the need to work together. And that was my point about the last question that I posed. Can science go at it alone? And the reality is, no, it can't. I think these conversations require much more thinking and dialogue with theologians and ethicists and the public to really ask those, is this what it really is for the benefit of mankind? And even so far as to ask, do we even know what is best for us? And I think those are important questions, but what will happen, what would happen, it's a bleak thinking that way. I tend to think that there is some, maybe I'm more of an optimist, but I tend to think there is some more ingenuity and creativity in humans that would avert that. But again, this is why these kind of conversations as science furthers, that we need to have more dialogue.
Absolutely, Doctor. And here's the other thing that I want to say before we transition, and that is, this is a good example, in my humble opinion, as to why science and religion and its leaders need to be together at the same table, because science is going to be dependent upon the religious or faith community for the ethical issues, the social justice issues. Potentially, if you have enough money and you can create a certain kind of child, you have the potential to recreate in a different form what Hitler was trying to do.
And it's a scary thought, right? The fact that we can manipulate much easier, theoretically, our genome for our children, and what that would imply in terms of access and privilege, and those who won't have access to it. And ultimately, are we creating do we have the authority to create that, and would that change humanity? And it's important to remember, I think from a scientist's point of view, what the scientific community has done really well, I think, is in that specific incidence of genetic engineering, is that as the technology, this was spurred in 2015 through the what's called CRISPR-Cas9 system, which is it's a bacterial system that was co-opted and discovered by scientists to make genetic changes in the genome much easier in the mammalian system than it was before. And it's not that we couldn't do it before, it's just much faster and much more efficient. So it raised a lot of these same questions. And what scientists, I think, have done a really good job is that as it was getting discovered and implemented, those scientists have engaged in those conversations. And I just there was a summit, and I wanted to share this because I think I'm quite proud that scientists thought about this, and there were theologians a part of this conversation, which is this thinking that if you see here, it says, we call on the scientific community to engage the ethicists. You see faith leaders. And so even scientists in this convening of how do we approach genetic engineering, they recognize that the conversation is bigger than the scientific community. And I give a lot of credit to those scientific leaders who are willing to engage. And I call on our religious communities to participate in that.
Wonderful. Okay, Dr. Kim, we have some questions. So is it okay if we go a little over in order to answer the questions?
I'm here as long as folks want to be.
Okay, thank you so much. Has DNA damage always been a fact of creation, or is it becoming more prevalent because of the choices we make in the modern world?
Great question. Whether I would say that mathematical geneticists, and I'm not one of them, computational geneticists who can kind of statistically trace back, they probably have much more insights into this, and I don't. But I can say that it's, from what I know, it's rather limiting to say that it's just, from what I know, it's limiting to say it's just genetic mutations. Whether we have more, we do know that we see different types of diseases, whether that is circular in the sense of, one disease impacts one generation and, another disease, another generation. That's harder to say. But at the same time, I think what I have gleaned from what I studied is that it's not just genetic mutations now, which is complicating the factor. It is that there are other elements of how we carry forth information. The beauty of science is that we can also detect them. And I think that there are medical improvements as well. And I think we take brightness in that spot, knowing that even if those mutations continue to happen, we continue to study them, and there are ways to overcome that. I should note that the other beauty of biology is that genetic wise, our biology is such that we correct DNA sequence wise. Correction for those errors is quite profound. I mean, I think the error rate in humans allows for spontaneous mutations without a lot of damaging impacts. And so there's a lot of beauty in that correction mechanism, as much as a lot of flexibility, even those mutations were to happen, that they wouldn't cause as much significant impact as you would think it does, because we're, in some ways, there's a lot of redundancies, there's a lot of complexity to this. But I take note in the bright part of medicine, even though we might see more diseases.
Okay. Are there any deductive or inductive reasons to say that these unexplained things are not ordered or natural? If there is something that isn't ordered, is there any reason to think a god or gods is responsible for it? If you can show a god is responsible, is there any data that points to one god to the exclusion of all other proposed gods?
So I think the stem of this question, often people say, I've heard in the science and religion dialogue, is that God is a God of order. And I do think in a theological sense, yeah, God is a God of order in our life. He brings order. in a biological sense, so I have to separate the physics of it here, because there's all these physical chaos theory and thermodynamics that I am a complete dunce at, so I'm going to just put that aside. I do know that because science can only measure a certain quantity based on a set of principles within the confinement of those sets of conditions, in terms of physics, chaos is, the discussion of chaos there is a little different. In a biological sense, I can say that randomness and chaos does have its place in
Yes.
biology. It allows for molecules, for lack of a better illustration, it allows molecules to hit each other and come up, and react and create biochemical reactions in our cells. And so the unique thing is other thing about biology is what we thought was chaos or disorganized is actually really ordered. So in the cell, for example, we all thought for a long time, many moons ago, I think, we thought in the cell, the organelles are just kind of floating. They don't know what they're doing. They're just bumping up in each other and molecules are just everywhere. It actually turns out in the organelle, in the cytoplasm, it's that liquid thing that everything floats in. There's a lot of cytoskeleton and structure within the cell. The other example, which I mentioned in DNA, is we thought all that 6 feet of DNA in a cell was just crammed in there without any order. Turns out if you look at it in a microscope, it does look like all squiggles and has no chaos, but it's actually really well ordered. Certain genes that work together are in certain parts of the nucleus together. And the DNA itself has structure. In our plain eyes, it looks like a bowl of spaghetti, but it's really not. And so how we define chaos, what we think is chaos, I think those are really interesting observations that I saw from biology.
Yes. And on Wednesday night, Dr. Kim, I'll talk a little bit more about this from a theological perspective, because I don't know if the person who asked this is coming from this particular view, but you get the Reformed theology that says everything is preordained and predetermined. And see, that's a theological perspective that I personally don't share. So there's a lot to this question on many levels. Was there anything else you wanted to say about that?
Nope.
Okay, here's a good one for you that will create for good dinner fodder with your husband.
Okay.
I have a hard time believing in miracles. They seem to suspend the laws of science. For example, the feeding of the 5,000. But you can't get something from nothing.
Yes. Well, physicists argue in the creation of the universe that the ex nihilo, creation of something from nothing, they would argue that we obviously have something from nothing. And so you talk to physicists as well. But in terms of miracles, Francis Collins in his book says it's not inconceivable to think that because he affirms evolution, but he also says that it's not inconceivable to think that God intervened to specially create or endow. If he is the creator of the universe and the creator of humankind through all its systems, it's not inconceivable to think that he has intervened.
Right.
Whether that's through miracles, through the natural suspension of law, or however he wants to intervene, or to the creation of Adam and Eve. And I take the same viewpoint. If God created everything, it is not inconceivable to think that he can intervene. And at the end of the day, I think what that question goes into is the fact that there's a lot of unknowns, and it's very uncomfortable, but there's a lot of things in the Bible that are very uncomfortable that we don't know, right? Questions about suffering, right? We sometimes, when we go through suffering in life, we ask, why is this happening, right? And it's the same thing with science and religion. There's a lot of questions we don't know, but what I often ask myself is, as a scientist and as a person of faith, what are the two key things? And the two key things is, I affirm that my calling under Christ is to serve as a scientist and those, in science engagement. But I also affirm that God is a God who honors questions. as we see from doubtful Thomas, right? Like, it's okay to not know for now.
Yeah.
And it's okay that I'm on this journey, and to be comfortable with the uncomfortableness.
Yes.
And to be comfortable with not knowing everything. And so, yeah.
I want to interrupt you for a quick moment because I want you to speak a little more about doubting Thomas. I think that's such an important point that I've heard you make in other interviews.
So I haven't really dived into this. So, Pastor Jeff can correct me on the theology. I've come to, observation that when the Bible talks about doubt, there seems to be two different types of doubt. There's a doubt as in rejection of God. But there's also a genuine, help my unbelief, God, kind of doubt, where we genuinely say that I acknowledge God, but I don't understand this in my life, right? Or I don't understand this in science. And that latter type of doubt is what I think Thomas had. Thomas knew the resurrected Christ as a person, but he just couldn't make the connection, right? And I think the fact that Jesus welcomed him to examine, I think tells us a lot about the personhood of Christ. And it tells me a lot about how I should live, not only as a person of faith, but as a scientist, or anything that I'm curious about in our life, is that it's okay. And that's why these kind of events like Courageous Conversations is so important, because we need to be able to have these questions and conversations to grow together. And so that's my ongoing thought about different types of doubt, but I don't know if it's biblically correct.
So Dr. Kim, when you have talked about Thomas so beautifully, because in the text of Scripture, when Jesus went to the home where the disciples were the first time, Thomas was not there. The text says he went back a second time in order to seek or to pursue Thomas. And so when he shows up, what does he invite Thomas to do? Examine him.
Yeah.
So you have said that so beautifully. I won't preach that text the same after I've heard you talk about it.
Thank you, but it's just doubtful Thomas is my bud.
My buddy. It's powerful. Okay, we've got a few more questions here, Doctor. Is someone with Alzheimer's who no longer has his or her original personality, do they remain a spiritual being?
That's a combination, I think, of psychology and I think theology. So let me break down the science of it first. Until modern science, a lot of cultures really didn't know what makes us us, right? And what makes us the soul. So the question of where is the soul, right, is still unknown, or where is consciousness? And the classic study that is that when there's brain damage, so like, the classic study, for example, of Gage, if you see Wikipedia or whatever, like somebody who in mid-century got a spike through his head and he lost his memory. So he lost who he was. And it kind of refers back to my memory in epigenetics is, if I don't remember who I grew up with, who my parents are, does that erase my identity, right? If I don't remember. So that's one question. So I'm answering a question with a question, but bear with me. But so if a person has Alzheimer's, it's the same thing. If they don't remember who they are, who their loved one is, do they lose their identity because they're not able to recollect? But I think that remembrance of identity is closely tied, but not the same question as if that person's soul/spirit. Because I think where the soul spirit conversation is very much of a theological, because what is unique about humans that God breath, as the Bible says, gave his breath onto Adam and Eve, that created that consciousness, right? The scientific conversation of consciousness or how we think who we are is very different than what believers think about consciousness and the soul and spirit. And I think it's important to distinguish that. But even in a science sense, we don't really know what consciousness is, right? If we were to able to create and clone the same person? Would that person have the same consciousness? We do not know. I mean, going back to AI, I heard a neuroscientist who's also a believer, and I told him I'll steal this, and I often do, which is he poses this question. He says, if we replace one neuron, because let's say we have, the technology to do it, we replace one neuron in our brain with AI, physical neuron, like a robotic neuron, are we still human? Probably. If you do it to two, probably. We have a billion, right? We have 100 billion. But if you do it to all of them, 50%, at what point do you lose that consciousness or become a robot? Or can you maintain that consciousness? Are we just our physical components? Or is there an element that God endows into humans?
Right.
That's a question for Pastor Jeff.
Well, one thing, Dr. Kim, that I want to talk to you about another time, but I do want to get your take on this briefly, because we've got questions piling up galore here, and we'll have to cut it off. I'm sorry, because we could go on all night. But so here's the thing that I'm going to make a statement, and I want you to respond to it, please. I think, generally speaking, scientists say we are our brain. And theologians say a brain is a part of us, but God doesn't have a brain, and God functions very well. So it's dangerous to put all of our eggs into the basket of our brain is what defines us.
True.
Because I've had mysterious experiences with people who have Alzheimer's severely. One in particular, she had not, well, let me cut it. I'm going to go off on a tangent. It just illustrates my point, but you and I can talk about that later sometime, and I can do some more work on that Wednesday night. But it's a powerful thing, doctor, because the person, the human person, I think science and religion have to dialogue about what makes us human, what makes us who we are in our deepest level of identity. Because I can have a person in the hospital who's brain dead, clinically brain dead. I can speak into their ear and I can get a response. Not always, but sometimes. And I know science has an answer to that. Correct? There's more mystery.
It goes back, right? It goes back to science is limited by what we can observe and measure. And death is interesting. And I know in our previous conversation, we want to talk about a little bit about that, but I would just say this is the definition of death is changing, right? We know that, right? Before it was, they're not moving, they don't have breath. Now we have the ability to look into people's brain and see activity. So the definition of when is dead, when a person is dead is changing. And so it just illustrates that science is limited by experiments and observation, right?
Yeah, exactly. So Dr. Kim, I've got to move off of that because there's one final question I think we need to ask. And then to the degree that you're comfortable, I'll get some of these answers to relay back on Wednesday night. So here's our last question for today. Do you see the theory of evolution as 100% true? Or do you have some misgivings? I have a hard time believing that all the different types of fauna could develop at random, no matter how many billion years are thrown into the mix.
So I won't dive into the archaeological evidence because I'm not an archaeologist. The thing is, it almost does not matter what I think. And I don't mean that to be lightly treading. I think I would like to leave space, rather than what I think, I would like to leave space for people to recognize that there are different viewpoints and that it is okay to have those different viewpoints. Questions like, those life forms before the, for example, de novo creation of Adam and Eve, or pre-humans. And we talked a little bit about at what point are humans, right?
Right.
And it is okay. I think that simply put, I affirm that there are records in our scientific history, that there are these records, right? Scientific records. Does that mean that I don't struggle with some of the lasting questions, as we already talked about? No, I still have those questions. But at the same time, I go back to what does this science tell me, and what does my faith tell me? And my faith continues to tell me that that it's okay to continue to have those questions. And again, when it comes to evolution, it's really about how one views that viewpoint in whatever process we're talking about, humans or animals or fossil record. Does that change the ultimate question about significance? And does that change the story of how God endowed Adam and Eve, or what makes humans humans, and that God seeks a relationship with humans? And it doesn't. It really doesn't. And I think I challenge our brothers and sisters to really think about it that way, that there are different viewpoints. And I'm happy to outline those viewpoints of how people read, whether it's in Jewish contextual culture or whether it's in the more literal sense. But at the end of the day, I again and again emphasize that it is a story about significance, and it's a story about relationship, and to focus on that. And everything else is pretty much of a journey. I mean, I will be the first to admit that how I think about one thing has changed a lot.
Well, Dr. Kim, can I underscore one quick thing that you said? And that is that it's a journey, it's a process, and that's where your humility comes in, because you don't come off as I'm the expert, I know it all. So you're open to mystery, you're open to growing, right? But here's the thing, is that you named something very important relative to evolution. See, I personally believe God is the creator of all that is, and that God can use whatever means he desires.
Right.
I believe that evolution was the method that he brought much of creation into being, and that's natural process. But you said something important that I want to underscore. There are different viewpoints, but let's keep the focus on meaning, significance, purpose, right? Did I hear you correctly?
That is very true. That is, I think, regardless of the viewpoints, I have met committed. The important thing is, I think, again, going back to the stories, don't fall into the idea that you must commit to one. I think it's important. I've met committed Christians who are scientists with different viewpoints. And it's important that they all have, dedicated faith lives, but they all think differently. But this is what makes us humans unique. I think we're the only ones who ask these kind of questions. And that in itself is remarkable, right? Where did we come from? Those kind of significance questions.
Yes. So I'll close with this, Dr. Kim. Science and faith are similar in that healthy skepticism, our being willing to question what we believe to be true, is the best way to advance both our knowledge and our faith.
Absolutely. I think God
That's a
calls
profound
us.
statement.
Yeah, God calls us to know him and love him, right? So in that sense, I think it's really healthy for us to continue to have these conversations.
Well, Dr. Kim, you are so gracious to give your time to us. And Dr. Collins was right. You're the perfect person to be facilitating this conversation of bringing science and faith together. So thank you from the bottom of our hearts. Thank you.
Thank you.
For those
Thank
of you,
you.
It's a real honor and privilege. And I want all of you who are watching to know this conversation will continue on Wednesday night, 7 p.m. Central Time. It will be a webinar. We invite you to go to the Chapel Hill website and click at the top, and it will take you there. It'll be very interactive, just like this evening. I also want to say a word of thanks to the Kansas United Methodist Foundation for their grant, which has provided much of the cost of technology. We're deeply grateful. So Dr. Kim, thank you again. And those of you who are coming on Wednesday night, if you cannot participate live, we will record it just like this session. And with Dr. Kim's permission, this will be made available. So thank you, each of you, and God bless you.
Thank you.
Thank you. Bye-bye.